So your original data looks something like this. Can I hear a yes?
Yes.
Yes. Okay, so I would just make a few pages. I'm pretty sure you got to do that, right? Copy the next page. Okay. Page. Copy page. Add page. Add page. Maybe I'll make like 4 or 5 of them. And this will be useful for your screencast. Okay? Thank you. Alright, you guys good? And I can just toggle back and forth like this. And that's my original page. So in your screencast, you would be like, okay, this is our original data. We got this data by taking a video of a fan car, and you can see that as the fan car sped up, the slope gets steeper. Because the slope represents the speed of the car. Make sense? Okay, then you're like, okay, next thing we did is we made a best fit curve of our data, right? We did that. You guys did that by graphing x versus t squared if you were in AP, right? But in my college prep classes, we did it this way. And we just did analyze model. And if you look, there's a line here. And there's no way this line is ever going to fit our data because our data is in a curved pattern, right? So that isn't going to work. This isn't going to work. But then when we get to quadratic, all of a sudden it looks beautiful. It's not fitting our data yet, but it's close, right? I can just change my A term. Craig, would you change this to 0, please? And this to 0? Okay? Because what I want to do is start with the simplest case. And that would be when my B and C term are 0. Yeah. So hopefully, with a little luck, this will get us close to our curve. Make sense? And this is very close to what you got in AP classes when you graph x versus t squared. This is almost identical to what you got. Okay? It's slightly different. So it looks like about 5 is my A term, something like 4.9 or 5. Maybe I'll see if these can make it better. Maybe make them negative. I don't know. I'm just guessing. I don't know. I can't really do much better than that. It starts to look like my curve is not fitting my data if I play with my B and C term too much. Make sense? So I'm going to let it be. And there's an important button I'm going to press called Create Calculated Column. Are you guys good with that? That's going to make this possible. And think about it. I'm essentially making a best fit curve. That's all I'm doing. Cool? And this equation right here, the AT squared plus BT plus C with my A, B, and C values, log repos is going to take all these times, and it's going to make a new column. That's why I checked create calculated column. It's going to use this equation to calculate another column. And it's going to and do that super fast. Watch. See, it's done. Make sense? And I'm like, there, let me move this over. Probably the only thing I don't like about Log Pro is it hides stuff. It makes stuff and hides it, which I hate. So that's why I made my data table bigger. The CC stands for calculated column. That means nothing to me. So I'm going to rename it best fit curve position. Does that make sense? Yeah? Yes? Yeah. Best fit curve position. And then we'll call this X for position, because it's still position. And we'll put centimeters, because this data set, the units are centimeters. And this is how Logger Pro calculates this, right? And I'll just hit OK. So now we have this labeled column. And you could say, yeah, this is how we modeled the position time graph. We have an equation that's essentially position equals 4.9. Now you know from graphing x versus t squared that the units are centimeters per second, or 1 second, okay? And that's our A term. And then we have a B term of negative 0.4. And that goes with t, okay? And then we have a final term that looks like it's negative 0.1. Now, if this equation is actually going to make sense, position is measured in what units? Centimeters, yeah. And you'll notice that when you plug in centimeters for t, those centimeters squared cancel with these seconds. Sorry, I said centimeters. When you plug in seconds for time, the seconds squared are going to cancel with the 2 seconds there to give you what for this term? Okay, so this term here, the 0.4 times t, must also simplify to centimeters, right? Thus, the 0.4 must be measured in what units? You guys got it. So this has to be centimeters per 1 second, yeah? And then the final term, if it's going to simplify to centimeters, so that we have centimeters plus centimeters plus centimeters equals centimeters over here, what is this last term after measuring? Centimeters. Okay? Now, that's about as far as I can go with this. Done deal. I'll come back to this later. Does that make sense?
Yep.
So now, I'll just delete this, go to the next page. Okay? So page 3. And it looks like I have all of my new data. What did we really want that we didn't have in this data set right here? We have a best fit curve, but what are we missing? What's our other investigation? Position versus time, and our second investigation is? And these 2 investigations will give us a model for changing velocity. Does that make sense? So there's really 2 parts to this lab. So really we want velocity. And the way you did it last night, which is painful, I agree, is you drew tangent lines in. You found the slopes, and those were your instantaneous velocities, right? Okay, now, log or book do this. All you have to do is go data, new calculated column. We'll write instantaneous velocity there. You got instantaneous. I think you want instant. Yeah, there you go. You're awesome. Instantaneous. That's good. Instantaneous.
Yeah.
Well, I think there's an E. I think there's an E there. There's an E right there. T. Okay, and then write capital V with an INST, something like that. So it's a nice symbol.
What am I doing?
Yeah, INST or INS or something. After that, yeah, there we go. Just to distinguish, so we don't think that's an average velocity. The units, what are they, everybody? Go, Mohammed.
How come we don't like the subscript?
Oh, it's pain. I can't. Yeah, for subscripts, I can only put numbers.
Oh.
That's the only reason. I would. That'd be cool. Now.
I didn't do units.
Oh, we need units. You guys are awesome. What do we put?
Oh, where's the...
Alright, so what we need is to tell Log Pro how to take the slope of the tangent line everywhere. Right? We just got to figure out how to tell it to do that. And in calculus, there's a term for finding the slope of a tangent line. It's called a derivative. Yeah. So you go functions, calculus. So you, even though you may not be in calculus, yeah. And then wait, hold on a second. Hold on. Hold on. Where I got confused is I before the way I used to do this is I'd have Log Pro take the slope of our data. In other words, the slope of positions. And you can see that's going to have a lot of error. Do you get what I'm saying? Consider, instead of taking the slope of our data, didn't we make a nice, beautiful best fit curve? Yeah. Use that, dude. Because then you're going to have this beautiful curve, and your tangents will be nice and smooth. Does that make sense? So, I'm not going to choose position. I'm going to choose what?
That's good.
Beautiful. And then put a comma, please. And then I'm going to choose time. Okay? And if I just hit done, what do you think it's going to look like? Okay, so go ahead and hit done. Okay? And now if I go here, I'm on page 3 now. Kind of cool. Slightly cool. It's like gorgeous. And I'm gonna give you a moment. I'm gonna auto scale from 0 first. I'm gonna give you a moment to try to notice the pattern I was hoping you'd all see today. Okay? I want you to look at the slope of your instantaneous velocity graph and compare that with your A term. We'll go back and forth a couple times while you talk about it. Go ahead, you got 20 seconds. Compare that A term with the slope of your velocity time graph. You should see something beautiful. You got about 10 seconds. Aaron. You guys see it? Alright. And object. Oh, not that one.
Ah, that was my bad.